Model rockets launch vertically with an engine that is ignited at time t equals 0. The engine provides an upward acceleration of 30 meters per second squared for 2 seconds. Upon reaching its maximum height, the rocket deploys a parachute and then descends vertically to the ground. Determine the rocket speed after 2 seconds firing of the engine. What maximum height will the rocket reach? So to find the maximum height, we first need to find the height it gains when it's accelerating. So we should probably use this one, since it gives us the displacement given the initial velocity, time, acceleration, and acceleration. So you have the displacement is equal to, we don't have an initial velocity, that's 0. So it's just 1/2 times the acceleration, which is 30, and then times the time squared, times 2 squared. And this is equal to 15 times 4, which is equal to 60 meters. Now that's the displacement when it's accelerating. Now, after it stops accelerating, we need to find its speed, and then we can plug it into this equation to find out the displacement when it starts getting accelerated by gravity. So to calculate the speed once it's done accelerating, we can just use this equation right here. So the final velocity is equal to the initial velocity, this is 0, plus the acceleration, which is 30 meters per second squared, times the time, which is 2 seconds. This will give you 60 meters per second. And that's the speed it will have to plug into this equation to figure out the displacement after it stops accelerating. So now we know that the final velocity is going to be at 0 when it's at its maximum height. So we can plug in 0 squared is equal to the initial velocity after it stops accelerating upwards, so 60 meters per second squared, plus 2 times the acceleration, that is minus 9.8, it's Earth's gravity, and times the change in x. It's really change in y, but it doesn't matter which variable you're using. So, and then if you simplify this, you get negative 60 squared over 2 times minus 9.8 equals change in x. And then you can simplify this to the second change in x is equal to 60 squared over 2 times 9.8. As the negatives just cancel. It's 9.8. Now if you simplify this, you should get 184 meters. And that's the displacement after the rocket stops accelerating. So now we need to find the combined displacement, which is just simply adding the 60 meters from the acceleration plus the 184 meters it travels after the acceleration. And then you should get 244 meters. And that is the maximum height of the rocket.